Everybody gets hungry. We eat 24 hours a day, 7 days a week, just to satisfy our internal hunger and bodily needs. But what about space? Does it ever get hungry?
Well, obviously space doesn't have emotions, but it has many processes similar to our own body's desire to eat. Take a supermassive black hole, which is an enormous object that stands in the center of galaxies, using its gravitational force to consume matter. It eats away at material just like we do, and just like how we burp when we're full, it produces a quasar. Quasars, or quasi-stellar radio sources, were first discovered when scientists noticed waves near radio frequencies being emitted from one point, like a star. However, as time progressed, we learned that these weren't stars, but were in fact black holes emitting intense jet streams of energy. Black holes exhibit strong gravitational forces that make matter rotate around them to form what's called an accretion disk. Much of this matter will continue to rotate around in a circular pattern, which explains why many galaxies are spiral-shaped. However, some objects don't have enough velocity to counteract the black hole's gravitational pull, and they'll slowly get closer and closer to it until they pass the event horizon. Before it gets sucked in, matter has gravitational potential energy because of the black hole's gravity. But as it gets closer to the black hole, its potential energy decreases. We know that energy can't be created or destroyed, so as a result, some of the object's potential energy turns into heat. Take this toaster for example. As the temperature increases, the metal inside begins to emit light. The same thing happens with matter near a black hole, except to such an extreme degree that it radiates waves across the entire electromagnetic spectrum. When the matter gets hot enough, it shoots out this light in the form of a quasar. But wait a minute, you said that only some of the black hole's matter gets consumed, and the rest of it just rotates around it. What happens when a black hole runs out of fuel? Well, once all the consumable matter is gone, the process of creating quasars shuts down, and the black hole becomes dormant. Our own black hole at the center of the Milky Way galaxy is dormant, but that doesn't mean quasars are irrelevant anymore. Many black holes are more than millions of light years away, which means we can still see quasars from currently dormant black holes because we're viewing light from millions of years ago. This can give us information on the origin of the universe and the Big Bang. The creation and production of quasars could also spark ideas for next-generation energy sources, since quasars are much more energy efficient than nuclear fusion. Although they're far away from us, quasars can make a big impact on our perception of the universe. If we can just use the knowledge at our disposal, we can be like the quasar, gobbling up information instead of food, and then projecting it outwards until we brighten up our entire world. Thanks for watching.